Hello, this is Mrs. Moon, and I am creating this video to help you understand a little bit more about solving inequalities. So we're going to start with a couple of examples here that just require two steps. So solving two-step inequalities. So looking at number one, we've got 3x minus 4 is greater than or equal to 8. Forgive the messy 8. But what we want to do is treat this kind of like it's an equation. What we do on one side, we do on the other. So we're trying to get the x alone, which means this minus 4 needs to be canceled. So I have to cancel it by adding 4 on both sides. Once I do that, the negative 4 and positive 4 cancel. I can bring down 3x. I can bring down the inequality symbol. And then I can add 8 and 4. That's 12. Now my last step, remember doing to one side what you do to the other, is to undo this operation between the 3 and the x. Since they're right beside each other, that's being multiplied. I have to divide. Division is the opposite of multiplication. So I divide both sides by 3. And I get x is greater than or equal to 4. So there's my final answer. X is greater than or equal to 4. Let's look at example 2. Again, what I do to one side, I'm going to do to the other. I know I want to get the y isolated, so first I want to cancel this plus 6 term. So the additive inverse for plus 6 is minus 6. So I begin by subtracting 6 on both sides. Positive and negative 6 cancel. Negative 3y comes down. My symbol comes straight down. Now this becomes negative 12 minus 6, or negative 12 plus negative 6. So negative 12 and negative 6 combine to be negative 18. My last step is division, but I want to remind you the rule that in inequalities, if you divide or multiply by a negative, you're going to have to flip the inequality. So I get y is greater than negative 18 divided by negative 3 is positive 6. Notice the inequality flips, and a negative divided by negative is a positive. So my final answer for example 2 is y is greater than 6. Okay, examples 3 and 4 get a little bit more complicated. We have parentheses. So the first thing we need to do when we have parentheses and we're asked to solve is we need to remove them. So to remove parentheses, we use a property that you learned way back when called the distributive property. So that means we're going to multiply the term outside the parentheses by all terms inside parentheses. So 3 times x gives me a product of 3x. 3 times negative 4 gives me a product of negative 12. 3 does not get multiplied to this 3x because this is not in the parentheses. So this plus 3x is just coming down. My symbol's coming down, and my 12 is coming down. Again, we're going to keep that lined up. Okay, now if I look just at the left-hand side, you should notice that we have some like terms here. When you have your two x terms on the same side of the inequality or equation, you can go ahead and combine those. So 3x plus 3x combines to be 6x, and then I'm going to bring down the minus 12. My symbol comes straight down, my 12 comes straight down. So now this looks just like example 1. It's just a two-step problem now. So from here, if you can get the distributive property and combine the like terms, you should be in some pretty familiar territory. Again, we're isolating the x, so we're going to add 12 to both sides to cancel that 12. That leaves me with 6x is greater than or equal to 24. Last, I need to divide by 6. This time, I'm not dividing by a negative number. It's a positive. So I'm going to keep my symbol the same. X is greater than or equal to 24 divided by 6 is 4. And I know I'm kind of squeezing that in there. So my final answer is x is greater than or equal to positive 4. Let's look at this next example. We don't have parentheses, but if you'll notice, I do have a variable on both sides of this inequality. Well, I don't like that. Over here, my variables were on the same side, so I combined them. Here, when they're on different sides, I want to choose one to cancel out. So basically, you're going to pick one to subtract off or to use the additive inverse with to make it go away. But what you do to one side, you got to do to the other side. So if I subtract 3x, I'm going to subtract on both sides. 4x minus 3x is 1x, or x. Bring down the plus 3. We haven't done anything with that. Bring down the less than symbol and bring down the 6. So now this is a real simple one-step problem. X plus 3 is less than 6. I'm going to subtract a 3 to get the x alone. And I get x is less than 3 for the final answer. Okay, number 5 is another one that has parentheses. So we're going to start with the distributive property to remove those. So negative 5 gets multiplied by x, giving us negative 5x. Negative 5 gets multiplied by negative 2. Negative times negative is going to be positive 10. And then I'm bringing down the other side. I have not done anything with it, just bring it down. Okay, now you probably notice, again, we've got variables on both sides. Well, what did we do up here? We picked one, the 3, and we used the additive inverse to cancel it. So let's do that here. Let's get rid of this. Negative 5x, I'm going to add 5x. And what I do to one side, I do to the other side. And it just so happens in this case, negative 5 and positive 5x cancel. Negative 5 and positive 5x, they cancel here too. So sometimes your variable cancels on both sides. Continue to bring down what you have left. This time I've got left 10 is less than or equal to negative 10. Now, is that true? Is 10, positive 10, less than or equal to negative 10? No, it is not. It is not less than, it is not equal to negative 10. So if your variable cancels and you come up with a statement left over that is false, I'm going to write down false. You don't have to do that, but this is just a reminder. The variable canceled, I get a false statement. That means that there is no solution. So you can use this symbol, which means no solution. It's called the empty set. Or you can say no solution. That means no solution. Okay? All right, let's look at number 6. Again, we've got parentheses. So we're going to simplify by distributing. So 2 multiplied by x is 2x. 2 multiplied by negative 6 is negative 12. Bring down symbol. Bring down 2x minus 12. Okay, so let's take a look at this. Let's subtract 2x to make this cancel. And let's subtract 2x on this side. And it cancels there as well. So let's bring down what's left. I end up with negative 12 is less than negative 12. So here I'm left with a statement. Question. Is negative 12 truly less than negative 12? No, it's not. Negative 12 is equal to negative 12. It's not less than negative 12. So this is another false statement. So when it's false, we're going to say empty set or no solution. I need to look at where I'm writing. Okay, so that one's no solution. Now, let me show you if the symbol had been different here. Let's pretend that the symbol was less than or equal to. And we got this for the result. If we got negative 12 is less than or equal to negative 12, is that true? Negative 12 is not less than negative 12, but negative 12 is equal to negative 12. So that is true. So when you get a true statement, okay, this is real important. There's a big difference in false and true. When you get a true statement, that means that all real numbers are solutions to the inequality. So we could say that all real numbers are a solution here. So if you get something that's true at the end, we get all real numbers. If you get something that's false at the end, you get no solution. That is, anytime the variables cancel out. If the variables cancel and you get something false, it's no solution. Variables cancel, you get something true, it's all real numbers. Let me show you one more example of something true you could get. What if the variables cancel and you get this? 9 is less than 10. Is that true? Is 9 less than 10? Yes, it is. So if the variables cancel and you get this true statement, you would also say all real numbers. And I'm running really sloppy now, okay? All right, one other thing I wanted to mention is sometimes when you're solving an inequality, you might just have one variable, but it's on the right side. So I just wanted to make mention that sometimes makes it tricky. Here, I would subtract the 12 because I'm trying to isolate the y. So when I subtract 6 minus 12, I get negative 6. Symbol comes down, negative 4y comes down. Then, here's where it gets crazy. If I divide by negative 4, you know that we got to flip the symbol, right? Because I divided by a negative. So it changes the direction of the symbol. And negative 6 divided by negative 4 is positive 3/2. I just reduced the fraction, okay? But oftentimes we do not leave an answer looking like this because the variable's on the right. So I want you to know that 3/2 is greater than or equal to y is correct. But also it is correct to say y is, notice how the inequality points to y. Keep it pointing to y. Less than or equal to 3/2. So I need you to know that these two statements are equivalent statements. 3/2 is greater than or equal to y is the same thing as saying y is less than or equal to 3/2. So I hope this tutorial helps you to be a little more successful in understanding how to solve inequalities. Good luck!